Right, this is the start of the physics classroom tutorial. I'm asking you on Monday, November 1st, to go to the physics classroom, click on your account, and then somewhere down here will be the topics or assignments. And one of those is going to be names to formulas 1 for Concept Builder. I'm asking you to do all 3 parts. So if you launch the Concept Builder, it should list your name when you go in there. If not, then you need to make sure you are logged in. So that's my name, that's my email. I want you to do the apprentice section, the master section, and the wizard section. All 3 of those. This is worth 3 points, or actually 4 points, 5 points, and 6 points for a total of a 15-point assignment. So I'm going to show one example from each of the 3 levels. You probably will want a periodic table available to you when you do those 3 levels. So I will make sure that I attach, oops, that's not the one I want. I'll make sure that I attach something like this that we've used before, as on Google Classroom. All right, so let's go to the apprentice level. In chemistry, there are specific rules for writing the formulas of ionic compounds having a given name. One or more of these formulas is breaking the rules, or breaking the rules. Select all the rule breakers. So the question is this sodium oxide NaO2? When I go to the periodic table, I'll look and I see Na has a charge of +1, O has a charge of -2. That means I need 2 sodium and 1 oxygen. So when I look at this, that's not what I have here. So that is a rule breaker. So I will click that. Notice it's behind bars. Barium chloride, BaCl2. So when I look at that, barium is +2 charge, Cl is -1. So I need 2 chloride ions for 1 barium ion. That is correct. Finally, Ca2O2. So when I look at this, Ca has a charge of +2, O has a charge of -2. So in a way it makes sense that this is balanced, but we wouldn't write it Ca2O2. The lowest common denominator would be CaO. So that is not the correct way to write that formula. So I'm going to check the answers, and data away, that is correct. If you ever need help with these, remember you can go to the Help Me, and it's going to give you information about how to write chemical formulas. Binary ionic compounds, things like that. Predicting charges from the periodic table. So I'm going to go back here. I'm going to go back to the main menu. Yes, I do want to return, although you should not return until you get this accomplished. If I begin the master level, now these deal with things where we have parentheses around these atoms. That tells you the valence charge of this particular atom in front. So for example, titanium 4 chloride means titanium has a valence or 4 valence electrons. Iron 2 oxide means this iron has 2 valence electrons. Cobalt 2 chloride means that cobalt has 2 valence electrons. So chloride has a charge of -1. If titanium has a valence of 4, so if you look, titanium is, trying to find it, could be +4, +3, and it says it's +4 here, then I would need 1 titanium for every 4 chlorides, because chloride is -1. So this is incorrect. Iron 2 oxide, that looks pretty good to me. So iron has a charge of +2 or +3, and it says in this case it's +2. Oxygen or oxide has a charge of -2, so that actually should be FeO. So that is incorrect. This would indicate that this iron has a valence electron of +1, or charge of +1. Cobalt 2 chloride, so I'll take a look at that. Cobalt is up here. It can be +2 or +3. So if it's +2 and chloride has -1, I need 2 chlorides for 1 cobalt. So CoCl2 is correct. So sometimes these can have all 3 be against the law or breaking the rules. Sometimes it's just 1, sometimes it's 2. Normally it's 1 or 2. So I'm going to check the answers to this. Hey, data away. So I got that correct. I'm going to go back to the main menu. And I'm going to go and take a look here at the wizard level. So this is a mix of the type 1 and type 2. And again, if you ever need help, you could go to this particular question if you need to. So BaO2, barium has a charge of +2, oxygen has a charge of -2, so there should be one of each of those in that formula. There's not, so that's against the law. I'm going to go over here because this looks simpler. Copper 1 sulfide, rather, pardon me, not sulfate. Copper, by the 1 here, says it has a charge of +1. Sulfide has a charge of -2. So if I have -2 and +1, that means I should have 2 copper and 1 sulfur. That's not correct. So here, magnesium nitride, well, nitride should have a +3, or -3, pardon me. Magnesium +2. So if I have 3 magnesium at +2 and 2 nitrides at -3, that does equal out, so that should be correct. So once again, I'm going to go back to the main menu. I'm going to return. And I've done at least one example through each of these 3 levels, so that should help you understand what to do. Good luck, and make sure you give it a good effort. Thanks.